Welcome to The Explainer. Today, we are tackling one of the most important security topics for any AWS developer, especially if you're gearing up for that DVA C02 exam. We're talking about how to securely grant programmatic access to your applications.
All right, here's how we're going to break this down. First, we'll talk about the big problem with static keys. Then, we'll introduce the modern, much better solution. We'll see how it all works in the real world, and then we'll wrap up with some absolutely essential security habits you need to know.
So, to get us started, let's just ask a simple question. This really gets to the core of why this whole topic is so critical, not just for passing the exam, but for your entire career.
And the answer to that question? Well, it almost always involves the villain of our story today, the static, long-lived access key. Here's a really easy way to picture this. A static key is kind of like a master key to your whole office building. If you lose it, you are in big trouble until every single lock is changed. But an IAM role, that gives you a temporary credential, which is much more like a hotel key card. It only works for a short time, for a specific purpose, and then it just expires.
And this quote just hits the nail on the head. The biggest danger happens when developers hard-code these static keys right into their source code. You make one little mistake, one accidental commit to a public GitHub repo, and bam, you've got a massive security breach on your hands. This is the #1 risk, and it's a classic exam question. Leaked static keys give attackers long-term, persistent access.
You know, when you look at it, these static keys are just a giant headache. They're a permanent liability because they never expire. They are a huge pain to rotate manually. And sure, you could try to lock them down with an IAM policy that checks for an IP address, but that doesn't change the fact that the credential itself is still permanent. If it leaks, it leaks. Oh, and if multiple ops use the same key, good luck trying to figure out who did what when you're looking at your audit logs.
Okay, enough about the problem. Let's talk about the solution. It's time to introduce the hero of our security story, the IAM role, and the temporary credentials it gives us.
So what is an IAM role really? At its heart, it's just an identity that your application can borrow or assume for a little while. It lets your app get the permissions it needs right when it needs them without ever having a permanent key of its own. It's built for machines to talk to each other securely.
And the magic behind all this is a service called AWS STS, or the Security Token Service. You can think of STS as the security guard at the door. Your application doesn't have a permanent key. Instead, it goes to STS and says, "Hey, can you vouch for me?" STS checks everything out and then hands over a set of temporary keys that are only good for a short amount of time.
Now pay close attention to this slide because this is a huge deal for the exam. You have to know the difference here. Notice the prefixes. A long-term static user key will always start with AKIA, but a short-lived temporary credential from STS, that's going to start with ASIA. If you see ASIA, you know for a fact that it's a temporary key that's going to expire soon.
All right, so we've met our hero. But how does it actually work out in the wild? Let's start with the most common place you'll see this: inside applications running on AWS services like EC2.
There's a reason AWS pushes so hard for you to use IAM roles on services like EC2 and Lambda. And here are the 3 big ones. First, you get automatic credential rotation. AWS handles it all for you. Second, you never have long-term keys sitting on your server, which drastically reduces the damage if that server gets compromised. And third, you can manage all your permissions in one central place. It's just better in every way.
So how does that automatic rotation actually happen? It's pretty cool, actually. When you have an application on an EC2 instance, it doesn't need any keys hard-coded. It just makes a simple request to a special local address called the EC2 metadata service. The instance profile that's attached to that EC2 handles all the messy work of talking to STS, fetching fresh credentials, and rotating them for you, long before they ever expire.
Okay, that's great for stuff running on AWS compute. But what about the code that's not? What about that script on your laptop or your CI/CD pipeline?
So let's talk about when you're developing locally. The rule is exactly the same. No static keys on your machine. The absolute best practice is to use the AWS CLI with something called IAM Identity Center. You log in once, and it securely grabs temporary credentials for you that your scripts can use for just that session. It keeps those dangerous long-term keys off your laptop completely.
Now, for your CI/CD pipeline, like in GitHub Actions, the gold standard is a technology called OIDC. I know the name sounds super complicated, but the idea is actually pretty simple. Instead of storing a secret AWS key in GitHub, you just tell AWS to trust GitHub directly. So when your pipeline runs, GitHub gets a special secure token. It shows that token to AWS, and AWS says, "Okay, I know you," and issues back temporary credentials that are only valid for that one single pipeline run. No static keys ever.
All right, let's wrap things up with some really important hygiene and talk about what to do when things go wrong.
I want you to imagine the worst-case scenario. Your heart sinks, you see your access key posted online. It's a high-pressure moment, and knowing the very first step is critical, both for the exam and for real life.
The answer is immediate and non-negotiable. Your first move, before you do anything else, is to revoke that key. Don't stop to investigate, don't write a report. You go directly into the IAM console and you either deactivate or delete that key. That single action immediately cuts off the attacker's access and stops the bleeding. Period.
And hey, what about keys that aren't for AWS, like your Stripe or Twilio keys? Well, the principle is exactly the same. Never, ever hard code them. You use a service built for this, like AWS Secrets Manager. Your application, using its secure IAM role, can then ask Secrets Manager to get those third-party keys safely at runtime.
So how do you keep tabs on any of those old static keys that might still be floating around in your account? Well, AWS gives you a great tool for this called the IAM Credential Report. This is what you'd use to automatically check for any keys that haven't been rotated in the last 90 days, so you can enforce your security policies.
So we'll end with this thought for you. The modern way of thinking about AWS security isn't about how to hide your static keys better, it's about getting rid of them completely. When you fully embrace temporary credentials and IAM roles, you get to turn your credentials from dangerous liabilities into secure, dynamically managed secrets.